Hey everyone. So you have your Fortigate and its switchboard includes physical ports. Each can be configured with its own IP address or be associated to a virtual switch, either a soft switch or a hardware switch. That is, we are actually creating switches within the physical switchboard. But what is the difference between a soft switch and a hardware switch? Well, the difference is that in soft switch, the implement port 2, port 3, you all belong to a soft switch that we will name it marketing, and it will have an IP address of 10.0.0 and so on. In a virtual hardware switch, the implementation is done over the physical ports themselves, where each port, each interface is configured in its hardware level to be a part of the same hardware switch. That is a much superior way to handle traffic, and in terms of performance, it makes a huge difference. Now, whenever traffic enters the switch and it is destined to one of the interfaces that belong to that switch, decisions are made by the physical switch itself, its forwarding table, which is actually the MAC table. Alright, so let's configure a hardware virtual switch. Alright, so let's move over to our command line, config system virtual switch. And now if I'll type the get command, I will see that currently I don't have any virtual switch already configured. So let's name one. Let's call our virtual switch, let's call it marketing. And let's set it up from the physical switchboard. Alright, and now let's configure the different ports that will make out this switch. So let's use internal 4 and let's use internal 5 also, and let's use internal 6. Alright, let's get back to our... Alright, so now let's use the same command as before, config system switch, config system virtual switch, and let's see if we have a switch that is configured. Yes, we have. Here's our marketing switch. Alright, now let's refresh our interface pane to see our new virtual switch. And there it is. Now, if we will head over to our setting page of that switch, we can configure its IP address, its management. Let's use LAN2 as our alias, and let's get him an IP address, and let's that's right, I'm using the same. Let's allow anyone to connect to it using HTTP and HTTPS, and let's allow ping also. And every device, every appliance that will connect to that subnet will get an IP from its DHCP server. And let's also add up device detection. Okay. And there we have it. We have a hardware virtual switch with its own subnet, with its own DHCP server. Any appliance that will connect to it will get an IP address from its pool, and any traffic that will head up to one of the interfaces that is within the marketing switch will be forwarded using the forwarding table. Let me show you the best user setting tips for your Fortigate, and we start right now. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you have your users connected to one of the interfaces in your Fortigate and you want to set up different settings as authentication timeout and so on. So head over to the command line, config user settings, and the first command is set auto timeout. Let's move over between the different options, and there you can choose different integers from 1 minute up to 24 hours. Now the default is 5 minutes. Personally, I prefer to set the timeout to 30 minutes. So choose whatever suits you as an administrator and your company's policy. The second command is quite important. Set auto timeout type. Now there are different types of authentication timeout. There's the idle timeout, the hard timeout, and the new session timeout. What is the difference? In an idle timeout, Fortigate has to see traffic that is coming from the user. If it doesn't see traffic coming from the user's IP address for the time we configured as the authentication timeout, well, it deletes the authentication entry and asks the user to authenticate again. Now a file. Now after 5 minutes, the file download is not terminated. It still goes up and downloads to your computer. But if you head over to another site, that is, you create a new session, you will be asked to authenticate. Another option that every administrator needs to configure is the amount of failed attempts before the user is being blocked. That is the number of time a user can fail authentication until it is being blocked. Now the default is currently 5. You can change it up to 100 times. I usually use 3 times. So that is set auth invalid maximum, that is the maximum number of invalid login attempts, and let's set it to 3. Some of your user will probably head over through a captive portal, that is outsource employees and so on. So you can set the set auto portal timeout, that is the amount of time that those employees will need to authenticate again, to an integer of between 1 up to 30 minutes. One of the key elements of any authentication scheme is the usage of passwords. We use passwords all over in our FortiGate. We use it when we configure new users. We use it when we configure our admin profiles. We also use it when we configure SSL or IPsec VPNs. We use passwords all over. We will look at password entropy, how random or how difficult it is to predict your password. Let's start. So, an entropy in plain words is the difficulty in guessing a password, either in a brute force attack or a dictionary attack. Now, how do you calculate entropy? Well, you do it using the length of your password, the complexity of your password. Are you using uppercase characters, lowercase, or maybe you're using uppercase and lowercase? Are you using symbols? Are you using numbers? The more complex your password is, there is much more entropy. And the last parameter is the randomness of your password. The more random it is, it adds up more entropy. Now, randomness is an issue when it comes to computers, since computers can actually generate a pseudo-random numbers. All right, so let's look at an entropy example and things will be much more clearer. So we are calculating entropy using the following formula. H equals L. L is the length of your password. H is the total binary bits of an entropy. Entropy is calculated using bits. And N is the number of possible symbols in a password. So a password length of 8 characters from the entire alphabet, that is uppercase, lowercase, symbols, and numbers, will get us to an entropy of 2 to the 52. So this password has about 52 bits of entropy, and it is a strong password. The higher your password entropy, the less predictable your password patterns are for a computer. As far as password, 36, 37 bits of entropy are rather good. Another example is when we use a keylock that has only 10 digits, that is 0 to 9. So if we use only 5 characters, you know what, if we use 4 characters, we usually use 4 characters as our passwords in a panlock keypad. So that is 10 to the power of 4. 10 to the power of 4 is 10,000. So the key space of the password is 10,000 passwords. If we use 5 characters out of the 10 digits, it is 10 to the power of 5, which is only 100,000 passwords, and the entropy is only 16 bits. So this is not a good password in the digital world. It may be a good one in the physical world. If we use only lower letters in the English alphabet, we have 26 letters in the English alphabet, and we use a password of 7 characters. That is 26 to the power of 7. It gets us to a total of 8.3 billion passwords. The entropy there is 32 bits only, so still it is not a good password. If we use 8 characters out of the 26, that is 26 to the power of 8, we have 208 billion possibilities. That's the key space. The entropy is 37, which is quite good, though nowadays we use passwords with more complexity, that is using the uppercase and the lowercase plus numbers and symbols. We can use the command line to diagnose and learn more of our SD-WAN member interface. Coming up. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. We can use our command line while configuring SD-WAN for different tasks. One of them is to use different protocols that will be used towards the server that was chosen in the health check. So if we look at the performance SLA, let's choose one. And we can see that on the graphical user interface, we only have two options to ping our server, that is using ping and HTTP. Now, if we will use the command line, config sys virtual WAN link, config health check. Now let's edit the performance SLA that we have chosen, that is SIP. Let's see what is chosen. Show full configuration, and we can see that the protocol that was chosen is ping. Let's set protocol, and now you can see that we have the ping option, the TCP echo option, the UDP echo option, HTTP, and TWAMP. So that is something that is available on the command line and not on the GUI interface. Another thing that we can do, or actually see, using our command line, let's use the diag sys virtual WAN link. Let's choose the SIP. You can't see it that way. Let's choose the SIP health check. Now we can see the status of each member in our SD-WAN, in our virtual SD-WAN interface. In terms of packet loss, we can also see it on the graphical user interface, but that is also one way to look at the different members. We can see that it is alive. We can see that we have no issues currently with packet loss. And we can see the statistics for latency and jitter. Currently, the other members are not alive since I have not enabled them on my Fortigate. Now, whenever we use performance SLA, we are actually telling our Fortigate to probe different services. We can configure up to 2 servers that will be used as beacons. We are doing that to check the status, the health of the different members of the SD-WAN interface. Now, whenever our Fortigate probes that server, it is actually using a route entry that is created. Let's see that route entry. So we will use the get router info kernel, and those entries are actually flagged. They are created in the kernel. They are called fib entries, and they are flagged as proto 17. So to see them, we will use the grep command, and we will use the proto equals 17, and we can see, let's make that a bit bigger. We can see the different routes. They are being sent from the different interface gateway towards the different servers that we have chosen. The first one was actually the Google DNS server, which is 8888, and the second one is 1111. Hey everyone, so here we are at part 4 of Certificate Operations in your Fortigate. This video series spreads some light on the importance of certificates and why do we use them. It is not a tutorial of how to create a self-signed certificate. We will get to that. It is actually the theory behind digital certificates. So what did we have? We had symmetric encryption, where the two parties share the same secret key. We also learned of asymmetric encryptions, where we use a key pair, a public and a private key, different keys yet related mathematically. And then we had, at part 3, we had hash functions, a one-way function that takes any input and transform it into a digest, a hash value that is not reversible and is collision free. That is, no two different inputs can produce the same hash value. Alright, so let's connect the dots. A CA, which is a certificate authority, issues digital certificate. This digital certificate also contain the public key of the entity who requested the digital certificate. It can be just about any web server out there. Another thing that it does is signing the digital certificate. How it does so? It hashes the digital certificate along with the public key and then encrypts it using its private key, using the CA's private key. Now, when a browser connects to a secure web server, it gets the certificate along with a digital signature. Think about it as two different files. It opens the digital signature using the public key of the CA. It has the public key of the CA in its certificate root directory. Now, any browser keeps its certificates, its CA certificates, in a different place. Now, as the file is being decrypted, he gets the hash of the digital certificate value. He then takes the digital certificate, the original one, hashes it using the same hash algorithm that was used by the CA. The type of the algorithm is also present on the certificate itself. We can see it right here. If both hash values are the same, then we have a proof that the entity who sent the certificate is the one who it claims to be. So we have used asymmetric encryption and hash functions to prove the authenticity of the entity. Now, the two parties, the browser and the web server, will negotiate the symmetric encryption that will be used as the encryption algorithm, the cipher itself, to encrypt the communication between them. We saw that we can list processes, sort them out, and even terminate them whenever they demand too much resources. On our last part of knowing your processes, we will see how we can, in one CLI command, see the topmost CPU demanding processes. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. One of the features that we saw using the diag-systop command is that we can list the most demanding processes, either CPU and memory, using the M and the P character when it is pressed. Now, there is another command, which is the get system performance top, which lists only the most demanding CPU processes. Let's see it in action. So we use the get sys, sorry for that, get sys performance top. Now you will see the most demanding processes, the most CPU demanding processes at the second most right column. That's the CPU column. The most right column is, as we know, the memory column. Now you will see different processes such as the IPS engine or the antivirus scanner, new CLI, or even the SSHD, the SSH daemon. Now, whenever a process is too demanding in terms of CPU, you may need to kill that process, and we saw how to do it using the diag sys kill with a signal level and the process ID. Whenever you open an app in your Fortigate, you're actually creating a process. A process is responsible to ask the kernel for resources. CPU resources, RAM resources. How do you manage them? Using the diag sys top command. Let's take a look. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. There are some different ways to sort up the processes that are running on your Fortigate, but one of the most popular diagnose command is the diag sys top command. Now, whenever you launch the diag sys command, you will see the different processes that are currently running on your Fortigate. Now, you can filter those processes using the diag sys top, and now you can set up a number, an integer that will actually behave as the interval between the processes and the amount of processes that you wish to see. I've chosen 5 and 20. I have 20 processes, and the interval that they will refresh is 5 seconds. Now, let's take a look at the information that is being shown here. Let me stop just to look at those processes.